this? Well, I'm sure it will happen. I know that's what'll happen in November, but then we have to make up the date. It's supposed to be a really bad winter. Okay. We're learning. I want to invite you to learn. Thank you. It is recording. Hey, Brian. They were just talking bad about you, Brian. Okay. Let's keep going. Riemann Sums. So let's say we have a chart. Who can? Not that one. Here's our table. And let's say that this is someone driving. And I want you to estimate the distance traveled What? Oh. I was just thinking, I'm writing so large. I don't know why I'm writing this large. And you're like, I can't do that. Okay, estimate, here we go. Estimate the distance traveled in 4 seconds given the table. That's what the little arrow means. Given the above information. I don't know. Because I can't spell very well. I don't think it does. I'm glad we're all bad at spelling. No, not for travel. Sorry. I even knew that in grade 12 when we studied Monday. Okay. I want you to estimate the distance traveled, and I want you to tell me what's the smallest reasonable estimate and what's the largest reasonable estimate. I'm going to give you about 3 or 4 minutes just to think and write stuff down. Don't talk to each other. Are you ready? You're still thinking. Okay, someone tell me what they have as an estimate. 37 what? Meters. Okay, someone else tell me what they have. 52 meters, someone else. Let me see your 8.
It's actually 8, 2, 3. Wait, no, you have to keep it. 8 to the 8 times 2.
Okay, anybody else? How'd you get 37?
I estimated the acceleration and
You estimated the what? To be what? How did you get that? Because like
No, I think
okay, so okay, 52. How'd you get 52? Three, 5, 8, 14, 22. Anyone else? Your last chance. Garrett? Why didn't you say that? How did you get 8? Sorry, that wasn't enough. How'd you get 8? Okay, Gareth, how did you get 49? You're good. Just say what you did. Okay, but then Jonathan did that too and got 52. So you didn't add 3. You just did 5, 8, 14. Why not 3? Yeah, this is good. I like it. Okay. Interesting. So, okay, these are the estimates. Did anyone do the largest versus the smallest? Y'all are so motivated. Okay, so here's what we're going to think. To figure out, given a velocity graph, to figure out how far you went, you have to multiply by the velocity by the time, right? Yes, okay. So if we have this, are you done? Okay. If we have this scenario. We don't know what happened between seconds 0 and 1. Like at 0.5, I have no idea how fast he was going. Maybe he was going a billion. I don't know. Okay? So we're going to use the information that we're given to try to come up with an estimate. So looking at the smallest estimate would mean that he was going the slowest. So we would assume, just like Gareth was saying, we would assume that from at time 0, we're going 3 meters per second. And we're going to go 3 meters per second until the last possible instant, and we're going to jump to 5. So if we were to graph this, here's our velocity. I shouldn't have drawn that like that. Scratch that. Here's 3. So our velocity is going 3 for a whole second. And then right at the last possible minute or second, it's going to jump to 5. And we're going to go 5 for another second. And right at the last possible moment, it's going to jump to 8. Do you see what I'm doing? Yeah. Okay. So I went 3, then 5. By the way, yeah. I went 3, then 5, then 8, then 14. Was I ever going 22? For one T90 instant. So we're not going to count 22. Okay? So how far did I go? 30? I'm trusting that you counted this? Okay. Cool. 30. Alright, 30 meters would be our smallest reasonable estimate. We could say 8, I guess, but it's not really a reasonable estimate. So smallest reasonable estimate would be 30. We got it? Okay. Our largest would be the same process backwards. So we're starting at 3, but right after, like the instant after we're going through, we're going to jump to 5. And then we're going to jump to 8. And then we're going to jump to 14. And then we're going to jump to 22. So in this case, we really weren't ever going 3, right? Just for one T90 instant, we're not going to count it. So we'd be going 5 plus 8 plus 14 plus 22, which is actually what Gareth did. And that's 49 meters. Does that make sense? Almost. Okay. So we have the smallest reasonable estimate, we have the largest reasonable estimate. Notice that when we draw it in this stair-step manner, we're multiplying the height of this by the width of this. We multiplied 1 second by 3. Multiplied 1 second by 5. 1 second by 8. So we were actually finding the area of these boxes, right? And we saw that the area here was smaller, the area here is bigger, right? This is the red number and this was the blue number. We get two different estimates. These are called Riemann sums. Riemann sums are estimating the area under the curve using rectangles. Okay? So for example, let's say we have the function x squared plus 3 from 0 to 4. I don't know why I drew a comma. It's weird. So the function looks like this. I didn't draw this well enough. Let's say 1, 2, 3, 4. Okay. My drawing is pretty bad, but that's okay. Stick with it. Okay. So here's our function. And can we find the area under the curve? Can we find this area? We can estimate it. Yeah, I'm totally with you. We can estimate the area under the curve using rectangles. So we talk about left-hand Riemann sums and right-hand Riemann sums. So this L sub 4 is a left-hand Riemann sum with 4 subintervals. Okay, if we're talking about from 0 to 4, if we have 4 subintervals, how long are the intervals going to be? 1. So if I want to find the left Riemann sum, if I'm starting at 0, I would find the y value at 0. And that's what I'm going to use for my subinterval. And then I'm going to say, okay, what's the y value at 1? It's right here. And that's what I'm going to use for the height of my rectangle. I usually do this on the computer because it looks really nice and neat on the computer, so sorry. This is why they're all uneven. I'm not a good drawer. Okay. So this is the area. Is the area that I'm going to estimate, am I going to have a small estimate or a large? Small. It's going to be too small, but that's okay. So to find L4, it's going to be, since all of these are times 1, I'm just going to write 1 times. Obviously, you don't have to write the 1, but I'm just showing you that we're actually computing the area. Okay? Height of 3 plus my height here, but how do I find my height here? Plug in 1, I get 4. Plus my height at 2, which is going to be what? 7. Plus my height at 3, which is 12. Do we care what the height at 4 is? No, we don't. So L4 is going to be what? 26. I'm glad y'all do math fast. 26. Now for R4, can y'all see red? Okay, whatever. I don't think you can tell that it's red, but that's okay. So R4 means we have the same, we have 4 subintervals, so same thing. Intervals are 1, what am I trying to say? The width is 1. To find the height, I use the rightmost point. So my interval here is 0 to 1. I'm going to use the point at 1. So this is going to be my height. Same thing at 2, I'm going to use that 2. And 3. And now I care about 4. So now everything in red is going to be what I'm estimating. Is this an overestimate or an underestimate? Over, right? Over. So I have, again, all of the widths are 1. I have the height at 2, which we said was 4. The height at 3, which was 7. The height at 4, which was 12. And the height, oh, no, I'm lying. This is the height at 2. No, 1, 2, 3. And now we need the height at 4. 19. So this is what? Are you sure? I'm trusting you. I know why I'm writing meters. 42. So we have L4 is 26, R4 is 42. These both estimate the area under the curve. Right? One's over, one's under. Oh well. Okay, what if we did M4? I'm going to draw another graph just so hopefully this isn't as confusing. Okay, so I still have 4 subintervals, but now, in order to find the height, so when we did L4, we found the height at the leftmost point. For R4, we used the rightmost point. What do you think we'll do for M4? Use the middle point. So I'm going to use the point at 0.5. I'm going to go up to wherever 0.5 is, and that's going to be my rectangle. Then 1.5. I wish I was good at drawing, I'm sorry. Okay, notice that M4, depending on whether it's an overestimate or underestimate, we may not be able to tell. Can you tell? From my drawing, it might be hard to tell. You think it's over? I actually don't know. I don't know. I think it might be under. It does. Anyway, so we may not be able to tell if it's an over or under, but look how much closer it is than either of these. It's a lot better, right? In this case, for this function, it's a lot better. So we have, again, all the widths are 1. But now we're going to find the y value at 0.5, which is going to be what? 3.25. Plus at 1.5. What's the value of 1.5? Are you sure? What about at 2.5?
12.5. No, okay, no, that's 9.5. Oh my god. Oh no!
Are you sure?
Okay, 12.25 is the net is 3.5. 2.5 is 9.25. So then we'll have a question. So add 9.25.
I don't believe you. Yeah, go. Hurry. This is the longest video. Feel bad for Brian who has to watch it. Yeah, I did. You could fast forward that part. What did you say, Henry?
They're all correct so far.
Okay. What happens when you add them all together?
15. You got to add the 3 at the end.
Oh.
Oh my god. I resign.
Okay, what do you get when you add them all up?
Oh my.
The 0.25s add to 1. 30, maybe. Okay, 30.
Whoa, no. 8, 9, 17, 15, 32, 33. Off point.
Okay, good. I'm glad I put a question mark. So glad I didn't commit to that answer.
Off point.
Okay. So we have L4, R4, N4. What if we wanted to do L8? Okay, now we have to have 8 subintervals. So how long are the intervals? 0.5. So remember that each time I'm doing a rectangle. So now my width is actually going to be 0.5. And then I have to find the y value if we're doing L8. I'll start with the y value at 0, which is 3. And then I'm going to find the y value at 0.5, which is 3.25. And then I'm going to find the y value at 1. And then I'm going to find the value at 1.5. And then at 2. And then at 2.5. And then at 3. And then at 3.5. And I'm done. Make sure you have 8. There's a good way to check. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. What is all that added up? Are you sure?
No. Can we scroll up to see the first one?
59. Okay, what is 59 times 0.5? 29.5. Are you sure? Okay, so notice that L4 was 42, no, 26, and L8 is 29.5. So the more subintervals you do, the better this approximation you get. And let me just show you that really quickly. Yeah, I can. I think you can. If you can't, that's unfortunate. I'll make a video. I know that if you're on the other version, it shows it to you. Let's see. Okay, notice that the orange shows you, this is L4. So they're choosing the, and this is actually good because it shows you kind of a different curvature. So we're choosing the leftmost point to create our rectangle. See that? Okay. Now, the more rectangles we get, notice what happens. What happens?
Follow the curve.
Yeah, okay, let's do this faster. It's getting closer to the approximation of the area of the curve, right? mentioned, spoiler alert, where do you think this might be going? Limit. I don't know what integrals are. But limits, right? Because the limit as the amount of rectangles goes to infinity, it becomes the area under the curve, right? That's where we're going with this. So we're starting with approximation. So back to what we were just talking about is that when we get more rectangles, the more accurate the approximation becomes, right? So L8 is closer to the actual area than L4. Okay, are you good? Okay. With your calculator, get your calculators out. Okay. For these problems, you can do them in your calculator, so I'll show you. So first of all, we have the change in x. This is going to be the width. This is the height, or it's going to be actually all of the height. It's going to generate them all. So we have width times height. So these are going to be rectangles, what we've been doing. Okay, so the change in x is whatever the width is. Like if we were going to do L8, on this last problem, the width would be 0.5 times. Now you need some sequence. Do you know how to get that? Catalog. There's probably another way to do it. Maybe if you get math. I have a calculator. I guess I can do it too. Yeah, I do. You're all dead. Except one. Okay, and actually, I should have told you to go to Y1 and plug this in. Or you don't have to, it's fine. Go. Okay, so 0.5 times. Yeah, times sum. So I think if you go to math. Oh, maybe I lied. I'm sorry if I did. I think it's somewhere else too. There's some. It is under math. No line. Okay. Oh, maybe that's not what I want. Okay. Do y'all have some? Do you have sequence? This is so slow. Some? Yeah, I was. So some sequence, and then for Y1, really, this is just a function. So if you have the function into Y1, you could recall the variable. But if not, you can just plug it in. So here I'm going to say x squared plus 3. Well, kind of. Okay, comma. I need x because that's my variable. So tell it what your variable is. Comma, your start and your end. Now, for these two right here, that you have to think. Because if you're doing a left 8, where is that going to start? What's my first x value that I want to plug into the function? 0. And where is it going to end? 3.5. So this is where you have to think about what would you actually start with, what would you actually end with. And then, comma, change in x, which is 0.5. And multiply that by 0.5. I didn't do that at the beginning, maybe you did. And see, we get 29.5. Yeah. 0.5. So A is the starting value. So whatever you need to write here to help you. This is the function. This is your variable. This is the start. This is the stop. This is changing x. So in our case, we would have x squared plus 3, x, 0, 3.5, 0.5. So what is this doing? Look, the sequence, when you have, okay, this part right here, just sequence this. This is generating y values. And it starts with 0 and it's every 0.5. So it's going to generate the value at 0, at 0.5, at 1, at 1.5. It's going to keep doing this until it gets to 3.5. This sum is going to add them all up. You see how this works?
Yeah.
Does it logically make sense? Awesome. Okay, what if I would do L100? Okay, so first of all, we would have, what is our delta x going to be?
4 divided by.
Yes, 4 divided by 100. Then we would have sum, sequence, our function, variable. Where are we going to start?
0.
At 0. Where are we going to end?
3.96.
How else could we have said that? I always say the end minus the difference. And you can actually just enter it in this way. 4 minus 4 over 100. Does everyone see why? And then 4 over 100. Go ahead, do this and see what you get. What'd you get? What does what say? Here? Oh yeah. X squared plus 3, comma x, comma 0, comma 3.5, comma 0.5. 33 what? Yes, 33.0144. What will work? Yeah? Let me see what you have. Let me turn this on.